Hello. Hello. Good morning, sir. Hello. Hello. Can you hear me? Yes, sir. నేను ఇంట్రొడ్యూస్ చేస్తున్నాను సార్ నేను. Good morning to one and all. Can you hear me? Hello. Hello. Can you hear me?
Yes, ma'am, we can hear you.
Yeah. Teachers need to integrate technology seamlessly into the curriculum instead of viewing it as an add-on, an afterthought, or an event. Dear esteemed resource person, G. N. Satish Kumar sir, participants, a very good morning to one and all. I am Mrs. Shweta Srivastava, the head Department of Mathematics and Statistics, RPVR Reddy Women's College, Hyderabad, and the coordinator of this national level 1 week online faculty development program on different mathematical and statistical softwares. At the outset, let me acknowledge the kind acceptance by the esteemed resource persons for sharing their expertise, experience, and knowledge for the benefit of the academic community in spite of the tough times and their schedules. Let me have the honor of introducing the resource person of today's program, Mr. Satish Kumar sir, data analyst at SR Software Solutions, Hyderabad, who will be enlightening the participants on SPSS software. Mr. G. N. Satish Kumar sir has done his master's in business management from Kakatiya University and MDCA from Jawaharlal Nehru National Youth Center, Hyderabad. He has expertise in varied statistical and data analysis tools analysis tools and packages like SPSS, MSOS, Smart PLS, VAR, PLS, R, Python, etc. Sir has conducted quite a few faculty development programs and workshops for faculty members, teachers, students, and research scholars. He is invited by quite a few universities, institutions, and organizations as a resource person. He has written more than 35 research papers in varied international and national journals. We are fortunate that he has readily accepted our invite to be a resource person for this faculty development program. I now leave the session to Mr. G.N. Satish Kumar sir to take over and share his expertise and experience with all of us. Over to you, sir. Thank you.
Satish sir, your voice is not audible, sir. Sir, your voice is not audible, sir. Satish sir.
Hello,
Yes, sir, we can hear you, sir, now.
can you able to hear, madam?
Yes, yes, sir, we can hear you now.
Okay, madam. Okay,
Okay, thank you, sir.
right. We'll start the session.
Okay,
Madam,
sir.
hello.
Yes, sir.
Right, madam. Is audio is okay for you, right?
Yes, it is clear, sir. I
Okay.
hope it is clear for all the participants also. Yes, sir, yes, sir. You can continue, sir. It is clear for
Right.
us.
Sorry for
O-
the delay. There's a small technical problem, but we'll start now.
Yes, sir.
Okay, I'm Jane Satish Kumar. I'm a data analyst. And let me do a small introduction about myself and I'll go into the subject. I'm a data analyst and I'm working for last 12 years in data analysis. And I have did around 180 plus PhD thesis analysis. And I have my own YouTube channel also. And if you're anyone is having interest, you can just see this YouTube channel, My Easy Statistics. I did analysis for not only for India, for also foreign countries also. I'm doing PhD thesis analysis. Okay, I have good knowledge and experience in handling SPSS data. So, with this small introduction, let us get into the subject. Today's topic is research methodology, and it will be an overview of research methods using SPSS. Right. In this session, I will be discussing the types of data, measurement types, data distribution, data normality test, that is Kolmogorov-Smirnov test, and hypothesis testing, type 1, type 2 errors, parametric, non-parametric. After this, we will be starting about different types of tests basing on the time availability. I will be discussing how many are possible, so many things I'm going to discuss. Is it okay? Hello? Madam, you
Yes,
can
sir.
respond, madam.
Yes, sir. Yes, sir.
In the meantime, you can respond because I
Yes,
need to
sir.
know whether my voice is coming to you or not.
Yes, sir.
So, you be on, madam, so we can discuss, other participants can hear.
Okay, sir.
Right, madam. So we will discuss with types of data, and the we are taking SPSS software because generally SPSS software is important software, is a predominant software in academics. And many people have an idea about SPSS. So in SPS environment, we will discuss about how to do different type of tests. And I am focusing mainly on the conditions under which different tests can be used. Is it okay, ma'am? Right. Now, this is SPS enrollment. I'm taking a small example of students' data, right? In SPS enrollment, we will be having two type of screens. One is a data view. The other one is a variable view. In data view, we have the total data. You can see this is the total data enter into SPSS. It looks like Excel only. And in variable view, we will be having all the variables. So if you have like 10 variables, in this case, I have 9 variables are there, like a student ID, gender, specialization, grades, score, and the teaching methods, 4 type of methods. This is the data for variable view. And in data view, we have the total entry of the respondents data. Total 105 respondent data is collected. Now, I'll start with the main point. So that is the data type. See, the first column, what we have is the name. This everyone knows it. And when we come for data type, we have 3 type of datas. Not 3 type. We have many type of datas. Basically, we will be using 3 type of datas. The one is a string data, numerical data, and a date. These are the 3 important type of data types which we'll be using. The string data is a character data, alphanumeric data, everything comes under string data. And numeric data, what are the numbers, whatever we want to enter, this all comes under the numeric data. And a date is a date. Apart from this, we can use any other type of data also. right? So this is the first column which you are going to select about string data. And importantly, in SPSS, when we enter data, generally all data will be in numeric form only. You can see here, all the data, even for gender also, I have entered as numeric only. Specialization, all data I have entered as a numeric only. Is it fine, madam? Can you hear me?
Yes, sir. We can hear you.
Right. So this is all data type. When you're coming, we'll be discussing only about three type of data. That is
All data will be numeric form.
numeric data and
All the
date. But generally, whatever data you take here, all the data will be in the form of numeric only. You can see even gender also have entered as 1 and 2. 1 means male, 2 means female. And very important in data analysis for us is measurement types. This is called measurement types. Whenever we have different type of data, we need to decide what is a measurement types. And we have three type of measurements. That is a scale data, ordinal data, and nominal data. Scale data is also called as continuous data. Continuous like marks. For example, you can see here GPS score is there. This GPS score is a scale data. And the marks also. Teaching method 1 marks, teaching method 2 marks. And in this way, we have taken all the marks. These all are scale data. And data which is in the order form, like first rank, second rank, third rank, if you're saying, or you're saying about grades, first grade, second grade, third grade, this type of data is called as ordinal data. And the third important method is called as nominal data. If you see gender is a nominal data because we are talking as male and female. So male and female are nominal data. And specializations. Here students have three specializations: marketing, finance, and HR. This is a nominal data. But when you're talking about grades, we have A grade, B grade, and C grade. This is ordinal data. And all other marks are scale data. Is it okay, madam?
Yes, sir. Yes, sir.
So in SPSS, where before we start the analysis and to use any test, these two important things should be taken care. That is what type of data type you are using and what is a measurement type you are using. And measurement type, I already said there are three type of measurement types. They are scale, ordinal, and nominal. So basing on the type of measurement only, different methods can be applicable because the different methods have different formulas and they work basing on the measurement type only. I think till here it is clear, right, ma'am?
Yes, sir. Yes, sir.
Right. So whenever we enter any data into SPSS, like any data we are entering, and before we start the analysis, we need to take care about what type of data we are entering, data type in this column, and we need to check the measurement types. And measurement type, I said nominal, ordinal, and scale data. Right. Now, once a data is entered, for scale data, we need to discuss about what is a normal distribution. See, scale data, I said like marks. We can have marks from 0 to 100. This is a scale data. And after deciding the measurement type, we need to check what is a data normally distributed or not normally distributed. If the data of a scale is normally distributed, we will be using parametric. And if the data is not normally distributed, we will be using non-parametric method. If the data is distributed, we'll be using parametric method, and the data is not distributed, not uniformly distributed, not normally distributed, it is called as non-parametric methods. So let us check for a GPS score whether the data is normally distributed or not. Even we can check for each individual scale data. We must check before we start the analysis whether data is normally distributed or not normally distributed. Why this is important? Because basing on the data normality only, we will be selecting what type of test can be used. If the data is normally distributed, we will be using parametric test. If the data is not normally distributed, we will be using non-parametric method. Now let us see a small glimpse of what is this normal distribution. In normal distribution, we will be having the mean, median, mode on the center. Means the data is uniformly distributed towards equal sites. Okay. And coming to the important thing, the amount of distribution, what is happening. In this red color, if you see, this is called one standard, which is 68%. The second one is 95% data is distributed. And the third one is 99.7%. I'll discuss what is percentage once we start the normal distribution. Okay. Now, is it able to understand, madam?
Yes, yes, sir.
Right. Now, what I'm doing is once a data type is decided, once a measurement type is identified, before we start selecting any statistical method to do analysis, it is important to see whether the data is normally distributed or not normally distributed. That's what I'm saying. I'm not started any test before starting the test itself. This is a stepwise which we must go. Data type, measurement type, and for scale data only, we need to check whether the data is normally distributed or not normally distributed. Okay, now in SPSS, we have a simple method to see about the distribution. In analyze, we go to descriptives, and in descriptives, we have descriptive again. Here, I want to check the distribution of GPS score. Now, in this GPS score only, I'm checking. We can check mean, okay, standard deviation, minimum, maximum. Continue, and just click here. Here we got the mean and standard deviation. Mean of GPS score is 2.7789. Standard deviation is 0.76. Now, standard deviation actually shows how much dispersion we have, variance we have. Generally, for standard deviation, when we do analysis, we'll see always the standard deviation must be less than 1. If the standard deviation goes more than 1, then we say data is not generally normally distributed. This is the first indication which we understand whether data is normally distributed or not. If you want to explore more and see about the skewness and kurtosis, we can do that also. We can go to analyze, descriptive statistics. In descriptive statistics, we have explore. In explore, we take dependent variable, and you can see statistics. Okay, just a moment. Okay. Here we will be getting all the information, how the data is distributed. We can see the skewness and kurtosis also. So mean, we can see median, variance. About the distribution of the data can be checked up about a scale data. Is it able to understand, madam?
Yes, sir. Yes, sir.
Right. What I'm saying is once the measurement type is decided, we need to see the distribution. Generally, this standard deviation must be less than 1. Generally, if it goes beyond 1, the distribution changes. Now you can see the diagram which I'm showing here. This red color is called as 1 standard deviation. This green color from this point to this point is 2 standard deviation. And this is 3 standard deviation. So if it is 1 standard deviation, 68% of the data is coming in this distribution. If it is 2 standard, it is 95%. If it is 3 standard, it is going to go with 99.7% of the total data is under that particular bell structure. Okay. Now, how to check if the data is normally distributed in SPSS or not? Can I go ahead, madam?
Yes, sir. Yes, sir.
I'm just showing the distribution here. I'm nothing showing a extra thing. Just I'm showing how to check the distribution. Now I'm going to show you in analysis part how to check the data, scale data is normally distributed or not. So we must go to analyze. In analyze, explore. In explore, select the variable which you want to do normal distribution. Take that value, and in plots, when you click plots, we have a button here called as normality plot. Normality plot. When you click this button and click continue and click OK, now directly we will be getting the test which is called as test of normality. So I'm checking the normality distribution of a GPS score. Here we'll be having two type of tests, madam. Kolmogorov-Smirnov and Shapiro-Wilks. Right?
Okay. Yeah. Yes, sir.
If the significant value, you can see the significant value is less than 0.05, data is not normally distributed. If this Kolmogorov-Smirnov is a test of normality, if it is less than 0.05, then the data is not normally distributed. Okay. Now we have two tests here. One is Kolmogorov-Smirnov, the other one is Shapiro-Wilk. If the sample size is 30 and more than 30, then we will be using Kolmogorov-Smirnov. If the sample size is less than 30, then we will be using Shapiro-Wilk. Is it okay, madam?
Yes, sir.
Right. You can see Kolmogorov-Smirnov, the significant value is 0.033. It means the GPS score is not normally distributed. If it is more than 0.05, it must be more than 0.05. Then only the data is normally distributed. But in this case, the data is not normally distributed. Why I'm using Kolmogorov-Smirnov? Because my sample size is 105. So I'm taking Kolmogorov-Smirnov and checking whether the data is normally distributed or not normally distributed. And you can see Shapiro-Wilk is used when the sample size is less, that is 30 or less than 30, we'll be using Shapiro-Wilk's test. And you can see this histogram. This is not in a bell form. Okay, madam.
Yes, yes, sir.
Yeah, this is not in a bell form. So we can easily conclude that the GPS score is not normally distributed, right? Now, we can do for other variable also. For example, I want to do the same thing with the test method 1 marks. Same thing in plots, we'll have normality. Click that one and simply say okay. And you can see the test of normality here. Here, this test of normality, the data is not normally distributed because the significant value, SIG value we call, this is less than 0.05. If it is less than 0.05, data is not normally distributed. And if you see the data, you'll understand this is totally skewed towards right side. Is it fine, ma'am?
Yes, sir.
Right. So these are the important things when we enter into SPSS. We need to check what is a type of data, what is a measurement type, and this normal distribution only should be done for scale data. Right? We must not do this normality distribution for ordinal data and nominal data. It only should be checked for scale data. And what is the benefit if we see whether data is normally distributed or not? Means if the data is normal distributed, then we can use parametric test. If the data is not normally distributed, then we must use non-parametric methods. Fine, madam?
Yes, sir.
Right. So this is what I'm saying in normal distribution. This is shows skewness, right skewed and left skewed, and kurtosis, height of the peak. So time is very less. We are not going to discuss much about this. Directly we'll discuss about parametric and non-parametric. Can I go ahead, madam? Any doubt you can have, you can ask at this moment.
Yes, dear participants, anyone has any doubt? You can message in the chat box.
Later we'll discuss, I think, later. Okay, ma'am?
Yeah, okay, sir.
Right. Now, what I said is just see the data type, measurement type, and check for scale data only, whether data is normally distributed or not normally distributed. If it is normally distributed, then we use parametric test. If it's not normally distributed, we'll be using non-parametric test. Parametric test assume normal distribution. For non-parametric, there is no assumption of distribution. Parametric test handles only scale data. Non-parametric test will handle even scale data, ordinal data, nominal data, any type of data it can handle. Parametric results can be significantly affected by the outliers. If there is an outlier in the data, that parametric data will be getting affected. But for non-parametric method, we don't have that problem. And parametric have more statistical power, non-parametric not so powerful. That's why when we do analysis, most people uses a t-test, ANOVA, because it is more powerful. That's what have more statistical power than non-parametric methods. And these are the type of tests which will be used for parametric and non-parametric, like two independent sample t-test, ANOVA, MANOVA. All these things comes under parametric test. For non-parametric, we'll have Mann-Whitney U-test, Wilcoxon sign rank test, Kruskal-Wallis test, Friedman test, Kolmogorov-Smirnov test, McNemar test. In this all comes under non-parametric methods. Okay, madam?
Yes, sir.
So basing on the data distribution for scale data, we can decide which type of test can be used, whether parametric or non-parametric. Parametric can only handle scale data, and that too data should be distributed. But non-parametric, there's not a problem. It can handle ordinal data, nominal data. It can handle scale data, which is not normally distributed. Outliers are not important. We don't take them into consideration. But why mostly we use t-test than non-parametric method? Many people, when they come, they want t-test, ANOVA. They ask us to do ANOVA. They ask us to do t-test. Then we ask, your data is not having normal distribution. Then why you want? Because their professor want to do. So obviously we do it. But to use parametric test, we have lot of conditions are there. Okay, ma'am. Now you can see this one, type of data and what type of test should be used. If it is nominal, ordinal, we must use non-parametric test only. If it is scale, you must check whether data is normally distributed. If you say no, then we must use non-parametric. If you say yes, then are the variance of population equal? You must check. Okay, and I'll discuss even variance also. If the variance is not equal, then non-parametric again. If the variance of the population is also equal, then we must use a parametric test. So these are the conditions which we have to handle with parametric tests. Is it okay, madam?
Yes, sir.
Right. Whenever we start with any test, for example, I want to use this GPS score. I want to check, is there any significant difference between gender, male and female, towards a GPS score? So when we start using any type of test, we need to have an hypothesis, and we create a null hypothesis. Generally, what type of null hypothesis we create when the case is that I want to see is there any significant difference between gender and the GPS score. I create a null hypothesis stating that there is no significant difference between male and female towards a GPS score. So always null hypothesis says there is no significant difference, right, madam?
Yes, sir.
Right. Now, when we say any statement null hypothesis, we are going to accept this null hypothesis or reject the null hypothesis. Fine. Now, when we accept or reject, it depends on confidence interval. It depends on confidence interval. It means at what confidence interval you are accepting a null hypothesis, or at what confidence level you are rejecting the null hypothesis. In social science, we take it as 95%. 95% as the confidence interval. Means 95% what I am saying is correct. Means we have how much percentage of risk we have? Only 5%, right? Now this 5% is what? 0.05. 5 means 5 by divided by 100 means 0.05. This 5% is called significance level. So whenever we make a hypothesis, we always state that what is the confidence interval? 95%. Then we say, okay, if it's 95%, it is 5%, that is 0.05 is significance level. And in medical science, they take 99% as confidence interval because the risk part is only 1%. 1 means 0.01. That is a significance level. Is it okay, madam?
Yes, sir. It's okay.
Yeah, please communicate, madam, so that I can understand that, okay, you are able to understand.
Yes, sir. If there is any problem, I just let you know, sir.
Right. Because I continuously, based on my experience, I'll be going fastly.
Yeah, no problem, sir. We are understanding, sir. We can follow you, sir.
I'm saying about data type, measurement type, and I'm saying about distribution, normal distribution. And when we start to use any test, the first thing what we must do is we must have a null hypothesis. When we have a null hypothesis, we need to accept the null hypothesis or reject the null hypothesis. So this accepting, rejecting depends on the confidence interval. In social science, like management area, we take always 95%. In medical science, when I go for dental college, another college, we do analysis for them at 99%. So risk is 1%, 99%, and 95% when we say only 5% is a significant level. Means at 5%, we accept the hypothesis or reject the null hypothesis, right? And generally here we need to discuss about a small thing, madam, that is
Yes, sir.
type 1 and type 2 errors.
Okay, sir.
Type 1 and type 2 errors means when the null hypothesis is actually true, but we are rejecting.
Yes.
This is type 1 error. We call it alpha. This is a significance level, what I said. Alpha means when I say a statement and I am saying reject it. Okay. So when what is the error I am doing? Alpha error. So this error should be very less. It should be less than 0.05 per 0.05. So a null hypothesis is true, but if I reject it, what is the probability? What is the chance that you are doing this type 1 error? Means it is 5% only, that is 0.05. But if the null hypothesis is false, but we are accepting it, this is type 2 error. Type 2 error, generally these medical people always looks towards type 2 error only. Social science people, we people generally go with type 1 error, because that's why we always call it alpha value. What is the significance level? I ask means what the null hypothesis you have made, and if it is true, you are saying rejecting. How much is the chance that you are rejecting it? Means I am taking only risk of 5%. Only a risk of 5% we are taking. So in social science, generally we talk about type 1 error only. This is alpha value we will be talking. Okay, then this is the same thing. The rate of type 1 alpha V shows its significant level, and the rate of type 2 error is denoted by beta, which is the power of the test, means 1 minus beta. So these are some of the simple things which you need to understand. What is the null hypothesis you have prepared, and whether you're accepting it or rejecting it. So these are the fundamental things which you have seen, madam.
Yes, sir.
Right. We have discussed about data type, measurement type of 3 types, I said: ordinal, nominal, and scale. If it is scale data only, check whether it is normally distributed or not. We are using Kolmogorov-Smirnov test, and we have found that the GPS score is not normally distributed. But many people, even the data is not normally distributed, they are using parametric test. Parametric test should be only used when it is normally distributed only. So here also we'll do the same thing. We will go to the analysis, and we will see about a different type of tests. Now from here we are starting the different type of tests, madam.
Yes, sir.
With a small, these are very fundamental things, what need to be understood when we start the analysis. Right. Now, first we will discuss about all parametric tests we will discuss, After parametric, we will discuss about non-parametric methods. Right. Now, when we start a test, there are one sample test will be there, two sample and more than two sample test, madam. One
Yes, sir.
sample test means we'll be using only one sample, only one data will be used. In two
Yes.
sample, we'll be having two variables. And
Yes, sir.
more than two, we call multivariate analysis. Is it okay?
Yes, sir.
Right. Now, in one sample, the test in parametric, what we'll be using is called one sample t-test. One sample t-test. For example, for GPA score only, I'm assuming the GPA score, the computed score, maybe 0.3 or 0. Okay, 3 I'm expecting. Right, madam?
Yes, sir.
I want to check whether it is correct or not. I just made a small hypothesis for this. In one sample t-test, I'm having a null hypothesis. The difference between the true mean and the comparison value is equal to 0. It means there is no significant difference between true mean and comparison mean. Here I'm going to use only one sample, that is GPA score, and I'm assuming that the mean score of this GPA is 3. And I want to do the test. Can I do it, madam?
Yes, sir. Yes, sir.
Right. We can write it that null hypothesis, there is no significant difference between true mean and comparison value. I'm taking comparison value. I'm expecting it to be 3. But actually, I don't know what is the true mean of this GPA score. In SPSS, analysis is very easy. We can simply go to analyze. In the analyze, we have compare means. In compare mean, we have one sample t-test. One sample t-test. Can I go ahead, madam?
Yes, sir. You can go ahead.
Here I'm trying to check one sample t-test with an assumption that this GPA score, the test value is 3. I don't know what is the true value. True value I am not checked it, but I am simply saying the test value is 3, and I am making a null hypothesis. There is no significant difference between true value and true mean and test value. At alpha is equal to 0.05. Right. Now, this is the test results what we have in SPSS. Okay. In one sample, you can see for GPA score, the true value is how much? 2.77. Right, madam?
Yes, sir.
And the test value is how much we have taken? 3.
Okay, sir.
And I'm having a null hypothesis saying that there is no difference between true mean and test value. This is my hypothesis. True mean is 2.7789 and the test value is 3. And my null hypothesis is there is no significant difference between the true value and the test value. Now, whether we are going to accept or reject depends on the significant value, madam. You must see always this value, which is called significant value. Can you see the value, madam?
Yes, sir.
Yeah, it is 0.004.
04. 04. Yes.
0.004. Here we make the statement, if the significant value is less than 0.05, we reject the null hypothesis.
Okay, sir.
If the significant value is less than 0.05, we reject the null hypothesis. Means what it means? There is a difference between true value and a test value. True value is 2.77. Test value is 3. Means there is a significant difference between mean value, true mean, and this test value. You can see the hypothesis. If the significant value is less than 0.05, we reject the null hypothesis. Else, we accept the null hypothesis. What is this 0.05? This is a significant value. Because already I said I'm taking type 1 error as a base.
Yes, sir.
At 95% confidence interval, my significant value I'm assuming as 5%. If the significant value in the test is less than 0.05, we reject the null hypothesis. So in this case, in the output, if you see it, the significant value is 0.004 and which is less than 0.05. So we are rejecting null hypothesis and stating that there is a difference between true, mean, and test value. So in this way, we can do the one sample t-test. Here we are only using one sample, right? So we call it as one sample t-test. Is it okay, madam?
Yes, sir.
Now, when you come for two sample t-test, we will be using two different samples. For example, I want to check whether there is any difference between gender and GPA score. Generally, people have a notion that gender-wise, there may be a difference in marks performance. So we'll be using this gender and GPA score. And we will make a null hypothesis in this form, madam.
Yes, sir.
Yeah. Two independent sample t-test. The test which you'll be using in this case is two independent sample t-test. What the test says, null hypothesis says, there is no significant difference between male and female GPA score. There is no significant difference between male and female GPA score. Now, why I am using two independent sample t-test? I have a small list of tests which must be used. Now, when I'm talking about gender and GPA score, madam,
Yes, sir.
gender is independent variable.
Okay, sir.
GPA is a dependent variable
Yes, sir.
because the score depends on the gender.
Okay, sir.
And this independent variable is nominal data because it is male and female, right?
Okay, sir.
But when I said the score is a scale data. And I'm expecting that this GPA score is normally distributed. ND means normally distributed. Then only I'll be using two independent sample t-tests. And important condition is that this independent variable, which I'm saying as gender, it exactly has only two levels, that is male and female only. Then only I'll be using t-test. Is it okay, madam?
Yes, sir.
If it is more than two levels, then I must use ANOVA.
Yes, sir.
You can see here ANOVA.
Yes.
ANOVA is one way ANOVA is used when their levels are more than two.
Okay, sir.
But if the dependent variable, which is gender, and independent variable is gender, dependent variable is GPA score. And I want to test, is there any significant difference between GPS score, difference between male and female towards a GPS score, I'm saying. So when you
Okay.
want to test this one, the method which I'm going to use is called two independent sample t-tests.
Okay, sir.
Important point when we use a t-test is it should have only two levels. And this male and female nature is independent.
Okay, sir.
What's the meaning of independent? Male has nothing to do with the female. This is a different group of people, and their females are different group of people.
Yes, sir. They are
So when the
independent.
nature is independent, then only we will be using two independent sample t-tests. Right, madam?
Okay, sir.
Right. Now we already framed a null hypothesis, and we are going to go for analyze. In the analyze, compare means an independent sample t-test. Here the grouping variable, that is a independent variable, is gender. We'll take gender and enter them as one is male, two is female, and GPA score I'm taking. Right, madam?
Yes, sir.
Independent variable is a gender, dependent variable is a GPA score. Click OK. Now here is the output. Independent sample t-test. You can see for male, the GPS score is 2.89, around 2.9 it is. For female, it is 2.59, around 2.6, right? So I can find there is a difference between the performance of male and female.
Yes.
But is it significant or not? That is my hypothesis. I am saying that there is no significant difference between male and female. So we must go to the t-test value, madam, here.
Okay.
In the t-test, you see the significant value. The significant value is 0.048. If this value is less than 0.05, we reject the null hypothesis. We reject the null hypothesis means we are saying there is no difference. That we are rejecting means there is a difference between male and female towards GPS score. Means performance of male and female are different. Is it okay, madam?
Yes, sir.
So this is two sample independent. I have shown the conditions under which we are going to use this two independent sample t-test. Is it okay?
Yes, sir.
Right. In data analysis, the first point when I started analysis, I said we need to check first the data type. Second is measurement type. If the data measurement type is scale, you must see whether data is normally distributed or not. Right, madam?
Yes, sir.
And if the data is normally distributed under the condition that the independent variable, that is gender, is exactly 2 levels, I'm using one independent sample t-test, right?
Yes, sir.
Right. So these conditions must be taken into consideration before we start the test, madam. So this is the condition under which we use two independent sample t-tests. Now, if the data is dependent, then we will be using same conditions. Independent variables are nominal only, and a dependent variable also is scale data. We'll be using paired t-tests. Paired t-test is used when the data is dependent. For example, I'll show this example. You can see the students are conducted different type of test teaching method 1, teaching method 2. Okay. And I want to check, is there any significant difference between teaching method 1 to teaching method 2? This is paid sample t-test. Why we call paid? Because same 105 members we are taking. We have conducted test for these people in different methods. We have taken in a standard teaching method, and with some animation method, we have some sort of audio video method we have taught them. And we want to see where there is any significant difference between teaching method 1 and teaching method 2. Then we will be using paid sample t-test. Is it fine, madam?
Yes, sir.
Right. So let us go to analyze, compare mean. Here we'll be having paid sample t-test. So training method 1 you can take, and training method 2. These are two different methods, but the data here is in scale data only. So I'm saying okay. Right. Now we must have a null hypothesis. The null hypothesis for this case is there is no significant difference between training method 1 to training method 2. There is no significant difference between for marks between training method 1 and training method 2. See the mean value. Training method 1, 7.47 score, but training method 2, the mean is 7.98. So there is a difference between here. Training method 1 is less performing and training method 2 is more performing. It is performing more than training method 1. But is it significant or not? We need to check this one. So for checking this one, we must see paid sample t-test. Directly we can check the significant values. If the significant value is less than 0.05, if the significant value is less than 0.05, we reject the null hypothesis. So it is 0.005, which is less than 0.05. So we accept or reject. We must reject the null hypothesis. So when we reject this null hypothesis, it means there is a significant difference between training method 1 and the training method 2. Able to follow, madam?
Yes, sir. Yes, sir.
Right. So I'm saying about different methods, madam. Like I said, first one is two independent sample t-test. You can see what is the independent sample you have, how many levels it has, and what is the dependent. Under this condition, we'll be using two independent sample t-test. If it is dependent, then we will be using paired t-tests. Is it okay?
Yes, sir.
If independent value is only one variable, but more than two levels, then we will be using one-way ANOVA. One-way ANOVA. Same conditions like t-test, but t-test is used only when we have two levels. But if it is more than two levels, we will be using ANOVA. Right. We'll see the example here for ANOVA. I want to check, is there any significant difference between specialization and GPS score? Specialization, I have more than two levels: marketing, finance, and HR. Okay, madam.
Yes, sir.
And GPS score is a scale data. GPS score is a scale data, and the independent variable specialization is nominal data. That's what I'm saying. The independent variable is nominal data, and the GPS score is scale data. The independent variable is nominal, but we have marketing, finance, HR more than two levels. Dependent variable is scale data. Then I will be using one-way ANOVA. You can go to analyze and compare mean and one-way ANOVA. Okay, when you click one-way ANOVA, I'm taking specialization as a factor and a GPS score as a dependent variable. GPS score as a dependent variable. Now, null hypothesis is that there is no significant difference between specialization towards GPS score. There is no significant difference between specialization and GPA score. And when I click OK, I'll get the output. This is the output. ANOVA, you can see the significant value. What is the significant value, madam? 0.055.
Yes.
Which is less than 0.05? No, it is more than 0.05.
Yes.
The null hypothesis we have framed is there is no significant difference between specializations towards GPS score. Means marketing, finance, and HR, we have specializations. I want to check whether there is any difference between these three specializations towards getting marks. System says we cannot reject the null hypothesis. If it is less than 0.05, then only we are going to reject the null hypothesis. Else we are going to accept the null hypothesis. Can we answer some queries, madam, if you guys are having any queries?
Sir, at the last of this session, we will be posting the questions, sir, by the participants so that you can answer that question, sir.
Right. Am I going speed, madam?
No, sir.
Is it okay?
It's okay, sir.
Right. So this is ANOVA, madam. ANOVA, we have simply said that is there any significant difference between specialization towards GPS score? So independent variable is only one. Dependent variable is also one. That's why we call two sample. But the independent variable, which is nominal, which is more than two levels. But a dependent variable scale data, and which is normally distributed. Then we'll be using one-way ANOVA. Right. Next, we'll be seeing about repeated measure ANOVA, madam.
Yes, sir.
Repeat ANOVA measure is also same. Independent variable nominal more than two, but data is a dependent. They're not independent nature. Like we have taken marketing, finance, HR. Marketing group is different. Finance group is different. HR group also is different, right?
Yes, sir.
But if you want to check between three methods like teaching method 1, teaching method 2, and teaching method 3. I have teaching method 1 is standard method. On board, we are teaching the students. Second method, we are using some sort of audio video method. The third method is experimental method. If you take consider like that, I want to check, is there any significant difference between teaching method 1, 2, and 3 towards a GPS score? Then I must use repeated measure ANOVA. Is it okay, madam?
Yes, sir.
Right. So same again, null hypothesis we are going to create that there is no significant difference between, teaching method 1, teaching method 2 and teaching method 3. Right. And if it is less than 0. If the significant value will be less than 0.05, what we do? Always we reject the null hypothesis. If it is more than 0.05, then we are going to accept the null hypothesis. Right. Analysis is very simple. We are going to go for general linear model in this repeated measurements. I think we are going in a very high speed. I don't know whether
No, sir, we are following, sir.
so many methods we are discussing continuously without break. Right, repeated measure. So the method, the analysis part is analyze. In analyze, we'll be having general linear model. In general linear model, we have repeated measure. Okay, so how many levels I want to use means I'm saying 3 levels I'm using. Don't bother about this. We'll take about teaching method 1, teaching method 2 and teaching method 3. 3 methods I want to compare. When you compare only two methods, we can use paid t-test. But if we are using more than 2 methods, then we must go with repeated measure ANOVA. Click OK. Okay. This is repeated measure. You can see directly, madam, here the scarcity assumed. This value will see. There's so many things to be discussed. You can understand so many things. Data is system generating so much values. But directly we want to see whether there is any difference between teaching method 1, teaching method 2 and teaching method 3 means directly you must see this significant value. The significant value is how much? 0.001, which is less than 0.05. So we reject the null hypothesis.
Yes, sir.
We are saying null hypothesis, there is no significant difference between teaching method 1, 2 and 3. But system is saying there is a difference between teaching method 1, 2 and 3. So we are rejecting null hypothesis. We must see the scarcity assumed value only. There are so many other parameters to be discussed, but directly I'm only focusing on whether you're going to accept the null hypothesis or reject the null hypothesis. So we say we reject the null hypothesis. So this is what is called repeated measure ANOVA. Till here, madam, if you see, all these values are only single values, one independent variable and one dependent variable, right? But if the independent variable becomes 2, we have 2 independent variables and only one dependent variable, then we must use two-way ANOVA. Is it okay?
Yes, sir.
Right. But what is happening? The intensity of the analysis goes on increasing now from here onwards. We are saying that instead of one dependent variable, we are going to have instead of one independent variable, we'll be having 2 independent values. But dependent is only one. Then we will be using two-way ANOVA method. Independent value variable is nominal. Levels are more than 2 only. They are independent. But dependent is a scale data. Then we will be using two-way ANOVA. Right, you can see this one data. I have ability of learning, different methods. Ability, there are 3 types of abilities are taken. And method, there are 2 types of methods are taken, blue book method and computer method. You want to see whether there is any difference between the score. Ability and method, these 2 are independent and score is dependent. And you can see ability and method both are nominal data. Score is only scale data. And I want to check whether there is any significant difference between the combination of ability, method towards a score. We'll be talking about interaction here. Means as we go on increasing the test, madam, the complexity increases. Is it okay, madam?
Yes, sir.
Because we are going on adding. Simple value is one sample I said. First I said is one sample t-test, right?
Yes, sir.
Where we have only one variable. But see, as the number of variables are going on increasing, the complexity of the data goes on increasing. So in two-way ANOVA, we will be having two independent variables and only one dependent variable. And this independent variable is nominal and the dependent variable is scale. Now, when you want to do this analysis for two-way ANOVA, and what is a null hypothesis? There is no significant difference between, we'll have two null hypotheses here. One is we are going to check with ability to score. Second one is a method to score. And even we can check the interaction of ability and method also. Three null hypotheses we can form here. The first one is ability, second one is method, and the third one is interaction of the methods. The first null hypothesis we can frame as there is no significant difference between ability towards the score. Second null hypothesis, there is no significant difference between the method towards the score. Third null hypothesis, there is no significant difference between the interaction of ability and the method towards score. In this way, we can go on increasing the null hypothesis. To do this analysis, analyze, compare general linear, and we go with the univariate. Yes, score is a dependent. Should I show the navigation once again, madam?
Yes, yes, sir.
Should I show it once again?
Yes, sir.
Analyze general linear in this univariate. In this, score is a dependent and these two are independent. Fixed factors I'm taking. And click OK. So two independent variables I have taken. I've taken two independent variables and one dependent variable. Now this is output screen, madam. Very simple to understand. First null hypothesis says there is no significant difference between ability towards score, I said, right, madam?
Yes, sir.
See the significant value. How much is the significant value? 0.033, right?
Yes, sir.
If it is less than 0.05, we reject. So is it less than 0.05? Yes. So
Yes.
reject the null hypothesis. Means there is a difference between ability to score.
Okay.
Second null hypothesis, method. Significant value is how much? 0.901. Null hypothesis, there is no significant difference between method towards a score.
Okay.
So this value, significant value is more than 0.05. So we accept this null hypothesis.
Okay, sir.
So when you're accepting means there is a difference between, there is no difference between method towards a score. And you can even see the interaction also, ability and method.
Okay, sir.
Interaction means combination of ability and method also we can check. Means the combination, the interaction of ability and method has no significant difference between towards the score. So you see the significant value 0.047,
Yes.
which is less than 0.05. So
Yes.
we reject the null hypothesis again here also. So this is two-way ANOVA. So we have seen one-way ANOVA, two-way ANOVA, repeated measure ANOVA. This one-way and two-way both are independent. In repeated, only this independent variable is having a nature called as a dependent. Okay, madam.
Yes, sir.
Right. And you can see here, important thing is in two-way ANOVA, we have independent variables are more than 2. Is it okay, madam?
Yes, sir.
Right. And when you come for MANOVA, the condition changes. Dependent variables will become 2. Independent variable will be 1. With 1 independent variable and 2 dependent variables, we're going to go with MANOVA. I'm not going to take up MANOVA because the analysis is somewhat bit complicated. And we don't have directly in this. So I'm just only showing the conditions, madam.
Okay, sir.
In MANOVA, dependent variable will be 2 dependent variables. And independent variable can be 1. Is it okay, madam?
Yes, sir.
So till now, whatever we discussed all comes under parametric test.
Okay.
And you can see all parametric dependent variables are scale data and normal distribution.
Okay, sir.
If they are not normally distributed, then we must use non-parametric methods. Then we must use non-parametric method. Right. I already shown you this one. These methods. So when you are using in parametric, same condition, we are using 2 independent sample t-test. In non-parametric, we must use Mann-Whitney u-test, madam.
Okay, sir.
In parametric, if the data scale and normal distribution, we must use whenever you are using paid t-test. In non-parametric, we must use Wilcoxon sign rank test. And in parametric, if we are using ANOVA and the data is not normally distributed, we can go with the Kruskal-Wallis tests. In parametric, if you are using repeated measure ANOVA, then in non-parametric, you must use Friedman test. Important thing is parametric can only handle scale data and data which is not normally distributed. Data which is not normally distributed. Data which is normally distributed, sorry. Parametric test must use data which is only normally distributed. But in non-parametric, we can use a scale data, we can use ordinal data, and you can use nominal data also we can use. And if it's using scale data, there is no condition that the data should be normally distributed. So it is very comfort to use non-parametric. But why many people are using parametric? Any answer, madam? You have?
No,
Hello?
sir. Yes, sir. Yes, sir.
Then why people are using parametric more? Because in parametric, you can have more sample size, but non-parametric generally it should be less than 30 only. What happens? The capacity of non-parametric test is very less.
Okay.
30 sample only. If you, for example, you are having very high sample, then we cannot go with the non-parametric method. Like 300, generally PhD data goes to 800, 900, they goes.
Okay. Okay, sir.
So their non-parametric should not be used. But as a statistician, when I'm doing analysis, what is happening is we depend on the interest of the professor only. They say, no, you do t-test, you do ANOVA. Then
Okay.
we suggest only them to please use parametric or please use non-parametric methods. So same test, madam, non-parametric also, you can, this is all non-parametric, which are reciprocal, means in this case, what are you using 2 sample independent, you must use Mann-Whitney test. Is it fine?
Okay. Okay, sir.
What I do is I'll use the same test what I used for t-test. Then I'll use for non-parametric also.
Okay.
Like for example, just now we said that, is there any difference between gender towards a GPS score? We said. Same test I'm going to use for Mann-Whitney U test, expecting that the GPS score is not normally distributed. Fine?
Okay, sir.
Right. Let us go to analysis. What is the condition we are using here? The method we want to check, is there any significant difference between gender towards a GPS score? Is it fine?
Yes, sir.
Right. Analyze. In SPSS, we have non-parametric tests. In non-parametric, we have legacy dialogues. Here, two independent samples, because I said gender, that is a male, female is two independent samples. Here, grouping variable is gender. We'll make it as 1 and 2, continue. And testing is GPS. And you can see these are all the tests which we can use. But I am taking as man white U test only. Click OK. So this is a man white U test. What is another hypothesis I have? There is no significant difference between male and female towards a GPA score. You can see the male GPA score mean rank is 57. Female mean rank is 45. Males are performing more than females. And see the test statistics. Significant value is 0.057. So we're not able to reject it, because if it is more than 0.05, we accept the null hypothesis. Is it okay, madam?
Yes, sir.
Now, what is the null hypothesis? There is no significant difference between male and female towards GPA score. That we are accepting, because it is how much the value 0.057, which is more than 0.05. And
Yes,
please
sir.
understand, the same test we have did between for two independent sample t test. Do you remember, madam?
Okay, sir.
There we have rejected. We said there is a difference, but now here we are accepting here. See the power of the test, because people take the, because there we, according to t test, which is data is not normally distributed, we said there is a difference between male and female, but here we are saying there is no difference between male and female.
Okay, sir.
So the test wise results will change. Right. Now here 0.05 means which is not less than 0.05. So we are going to accept the null hypothesis. Means there is a significant difference. There is no significant difference between male and female. Right. Can we go ahead, madam? Is it okay? Able to understand so many methods at once?
Yes, sir. Basically, sir, I am from the mathematics background, sir.
That's why I'm saying, because see, statistics have so much capability.
Yes, but I can understand this concept, sir. It's quite clear as you are explaining in a very simple
Right.
manner.
Right. Now this is what I want to focus for you, madam, because see, whenever you're using paid t-test, we will be using Wilcoxon sign rank test. In parametric, wherever you're using paid t-test, when we use paid t-test, you can see here, paid t-test is used when the data is nominal and independent. But see, Wilcoxon sign rank test, when we are using data is nominal, dependent, and scale, the dependent variable is scale or ordinal, but not nominal, nominal. Then what test we are using, madam? Wilcoxon sign rank test.
Okay.
If the levels are increasing, madam, from 2 level, if it is going to more than 2 level and they are independent, we'll be using Kruskal-Wallis test.
Okay.
And if the independent variable is nominal, more than 2 level, and they are dependent, we will be using Friedman test.
Okay.
And if it is nominal, 2 or more than 2, this is very important. Chi-square
Chi-square
test.
test.
From here, all are scale or ordinal, madam. But if the data becomes nominal, both are
Okay.
nominal,
Okay.
then we will be using chi-square test,
Okay, sir.
right? And if there are exactly 2 levels, then you must choose McNemer test.
Okay.
You can understand one important thing. Always independent variable is nominal only. Only dependent variable is changing. Right, madam?
Yes, sir.
Why? Because we are comparing between the impact of independent towards dependent. Always I'm saying is the difference between gender towards score, I'm saying. So this dependent can be changing, but independent always are nominal only. So the combination of tests what we are taking here depends on the dependent variable basically and the number of values it is having. When you come for independent, you must see the levels here. Exactly 2 levels or more than 2 levels, what levels you are using, these things should be taken care.
Okay,
Is
sir.
it fine, madam?
Yes, sir.
Now, if the independent variable becomes scale, for example, if this independent variable becomes scale, then what test should be used? Different combinations we are talking about. Is it okay?
Yes, sir.
Yes, I'll. Right. If the independent variable is becoming scale, you can see scale, and it is also scale, then we are using simple linear regression. Right? Correlation can be used or linear regression can be used, madam.
Okay, sir.
If it is only one, dependent is only one, and sorry, independent is one, dependent is one, simple linear. If independent increases, then it goes to what? Multiple linear regression. Is it okay, madam?
Okay.
And see, if the dependent, I'll just show you. If the dependent is becoming ordinal, then we are going to use what? Ordinal regression. If the dependent is nominal and independent is whatever it may be, it is going to become logistic regression.
Logistic.
And if both are scale, this is a very important condition which we actually face. Both are scale data and more than one. Dependent is also more than one. You cannot see that one. Only for MANOVA you can see this one, more than one. And here it is more than one, we will be using canonical correlation.
Okay, sir.
And if both are nominal and both are more than one, we will be using conjoint analysis.
Okay.
So the combinations, madam, we must see what is the data type first. We must see the measurement type, because all the story is going only with whether it is nominal, ordinal, or scale only.
Okay. Okay.
And we must, when it is scale, again you must check whether it is normal distributed or not normal distributed. And you must check what is the number of size of dependent and what is the size of independent.
Okay.
Both size should be checked. Basing on the combinations, the type of methods can be used.
Okay.
Right, madam?
Yes, sir.
In my YouTube channel, madam, I have explained about all these methods
Okay.
in a very clear form. I've explained about all the methods, even how to test, normality test, whatever I've discussed now.
Okay, sir.
Everything have explained in a very beautiful form. You can see about multilinear regressions. Okay, you can see basics of SPSS, all different type of tests, whatever test, even samples as how to determine also, I've explained in a very clear form, madam.
Okay, sir.
Different conditions, and they are because in research basing on different type of methods, type of conditions of data, the methods are going to change.
Okay.
Right, madam?
Yes, sir.
Right. And anything you want to ask questions, you can ask, madam.
Yes, sir.
Yes, sir. We have few questions from participants. Can I ask you, sir?
Please ask.
The first question is from Nilesh. How to make variable data manually?
How to take variable data?
Manually.
Means is asking how to collect the data.
How to make variable data manually?
Variable data manual, not question is not correct. Variable data means the data is what we enter. These are the variables, right?
Yes, yes.
These are the data. This is the data variable. This is all the variable data only, right?
Yes, sir.
What is the meaning of saying that manually?
So I have posted the same question, sir.
It's not correct. He's asking how to collect the data manually or how to enter the data.
Sir, the question he has made is how to make variable view.
How to
Make
variable
variable
view?
view.
Ah,
Yes,
this
she's
is a
asking
variable.
that question.
Yeah, this is a variable view, madam.
Okay, sir.
Here,
Hope it is
whatever
clear
you
to
want to
you,
change, you can go here and
Mr.
change the
Nilesh.
data manually. He's asking maybe because system generates, if I enter any value A, B, C, we'll
Yes,
get it
yes, sir.
automatically. So we can go
Okay.
here and change it.
Okay, sir.
Because data by default, say I enter something like ABC, system has automatically given some values. I can go and change it. Maybe this is the question. Right, my next question, madam.
He's asking, is it going to generate automatically?
System, when I enter XYZ, for example, system actually gives like this. What is the data type? Numeric.
Okay. Okay, sir.
So yeah, so many values system is giving automatically. You can go here
Yes,
and you
sir.
can make it manually.
Okay. Okay,
And
sir.
come to data view. In the data view, you can go on entering the values.
Okay, sir.
Right. Next question, madam.
If we have multiple choice questions, how to convert them into nominal variables?
When you have multiple,
Choice questions, how to convert them into nominal variables?
I'm not getting that. Multiple, what is that?
If we have multiple choice questions, how to convert them into
Solving
nominal
that.
variables?
Multiple nominal. I'm not getting what.
Multiple choice questions, how to
Multiple choice.
questions.
See,
Yes.
in a questionnaire, when you have multiple choice means it is multiple response analysis, madam. That is,
Okay, sir.
we call multiple response analysis. Okay.
Okay, sir.
The multiple choice means multiple response, right?
Yes, sir.
Multiple response analysis. Then how to do it? We have you can see here, just in my, I have shown here. Multiple response analysis is a video is there. You can see multiple response analysis.
Yes.
This is multiple choice. For example, you are asking a respondent to select multiple choice, right?
Yes, sir.
One thing is Likert scale means it is in order form. They can select any one of this Likert scale we call. Like strongly agree to strongly disagree.
Yes, sir.
But if you have given an option, like 5-6 options are given, and you ask them to tick one more than two, like in your house, how many electronic devices are there? You can tick more than one.
Okay, sir.
So when you're selecting more than one, you can go and select this one, multiple response analysis. How to use multiple response analysis using SPSS.
Okay, sir.
Yeah.
Hope it is clear for you. Next question, sir. Can we import the data?
Can we?
Can we import the data from other sources?
100% we can import from different type of formats of data, whether it is Excel data or whether in any other format, we can easily import into SPSS.
Next question, sir. Can we find p-value for testing the hypothesis?
That's what all the things I have shown is significant value means p-value only.
P-values.
Significant value is nothing but p-value only.
Okay, sir. Next question, sir. I think it is similar to multiple choice, but I want to repeat it. If we are collecting different ages of different countries, how it will be?
Different ages of different
Different
countries.
countries. Some
Where you
data
want to go,
related
make
to
it
some.
multiple, different age. What you want to do? What is the objective?
Just I request Durga Devi man to reframe your question, make it clear so that sir can answer your question.
What is objective, madam? Because we want to do analysis. When we do analysis, we'll see what is the objective or how we want to do analysis. Based on that, we can do the analysis.
Yes, sir. So these are the questions from participant side, sir.
Right, madam. See, the statistical data we have structured equation modeling
Excuse me,
also,
sir.
madam.
Excuse me, sir.
Yeah.
She
Please.
mentioned the objectives if you want malnutrition people,
Okay.
different ages of different countries. If object is malnutrition people, how can we relate?
For example, here your age is one independent variable, madam.
Okay, sir.
Country is another dependent variable. Malnutrition value is dependent, right?
Yes, yes.
So when we have two independent and one dependent, see this scale. In independent, we have two, right? and a dependent is only one because
One.
malnutrition you're saying, then use two-way ANOVA.
Two-way ANOVA.
Because independent, he is saying country and country and age, because it become two, right?
Yes.
You want to check a bit for what? For dependent variable. What is the dependent variable? Is only one. Malnutrition value is a dependent variable.
Yes.
So you must collect what is the age of different respondents. You must collect which country belong to, India, Japan, Sri Lanka, or whatever countries you want to belong. And dependent variable is scale. Then two-way ANOVA.
Okay, sir.
Just
Next.
keep that variables in this matrix, madam. Then automatically shows it itself shows whatever test you want to use.
Okay, sir.
Right, madam.
The
Next,
next one is SPSS package is open source or paid?
It is paid.
Yes, it is
It's a
from
paid,
IT.
madam.
Yes.
It's a paid software.
Okay, sir.
The people can use PSPP software, which is open source.
Okay, sir.
PSPP. I have did some all.
PSPP, it is
I
open
just
source,
show
sir?
you. Yeah, I'll show you PSPP. Oh, I forgot. This all shows on some of PSPP. This is software, madam. Statista is using PSPP.
Okay, sir.
PSPP software, which is open source and which is a replica of SPSS only.
Okay, sir.
And it is easily we can install and easily we can use, but capacity is less. So the number of tests which we can do in that is very less.
Okay, sir.
Right, madam?
And how to manipulate effectiveness studies, sir?
How to manipulate?
Effectiveness study.
What manipulation you do?
Yes, sir. Give me 1
Manipulation to
minute.
what?
Yes, sir.
Is it manipulating data? Is it manipulating the result? What is manipulating?
Yes, sir. Just give me 1 second, sir. Let me. Yes, sir. That's all the questions from participant
Right,
side, sir.
madam, because the time we have is very less.
Yes.
And methods we can discuss significantly. So, and only request is people, if someone is interested, you can go to my Easy Statistics YouTube and contact me for data analysis or any other things. Is it okay, ma'am?
Okay. Sir, can you tell, they're asking how much do it cost for SPSS if we want to buy?
6 lakhs, some 4 lakhs, 3 lakhs. It depends on the license, madam.
Okay,
But
sir.
it will be lakhs only.
Okay, sir.
They can use PSPP, man, not a problem, because I have taken, see, this test where using Python, because I teach Python also.
Okay.
And I teach R language also. Whatever method we are using, whether using any Python, R, or using any other software, this table statistical method is same.
Okay, sir.
Tests are same. Only thing is here I have taken the base as SPSS. You can take Python, you can take R language, anything you can use also.
Okay, sir. Over to Shweta, ma'am.
Yeah.
Shweta, ma'am.
I thank all the participants, our secretary cum correspondent, Professor G. Sudarshan Reddy sir, for participating in this session. Now I thank our today's resource person, G. N. Satish Kumar sir, for enlightening the participants in this session. I also thank our host, D. Harita ma'am, for conducting this session smoothly. Thank you one and all.
Yeah, thank you, madam.
Thank you, sir. And basically, I am from the mathematics background, but as you have explained clearly each and every step, I just understand clearly, sir.
If you give me more time, madam, I can really explain it very well, because I said no, I have a lot of experience in this subject.
Yes, sir. Sure, sir. We will conduct some other day, sir.
Right. Thank you. Thank you for your
Thank you, sir.
cooperation. Thank you for the opportunity. Thank you.
Thank you, sir.